to show you how to find the distance from a point to a plane. Let's consider a point Q and a point P on the plane. The distance, the vertical distance from Q to the plane is classified as d. From trigonometry, we know that d divided by PQ in magnitude is the cosine of the angle theta. So d will be the magnitude of PQ times the cosine of theta. Now, if I multiply this by the vector n, that is the length of n, where n is the direction of the plane, and divide by the magnitude of n, we have distance d. But notice, this is PQn cosine theta, which is the dot product of PQ and n divided by the magnitude of n. And this is the formula that we use to find the distance from a point to a plane. As an example now, let's take a point Q, 1, 2, 3, and a point P in the plane, and look for the distance between the point and the plane. So what I need is a point on the plane. What I'm going to do is say that d is pq dot n over n. So pq is going to be this vector, 1 minus whatever the coordinates of PR, 2 minus whatever the coordinates of PR, minus 1 minus whatever the coordinates of the PR, and I need a point P on the line. Well, this is the equation, the point P on the plane. This is the equation of the plane. So let's find a point P on the plane. Let x be 0. Let y be 0. And then 3z will be 12, so z will be 4. You can find any point on the plane that you like. This is just a convenient one. You could do 0, 0, 3 if you wanted to. So here is my point P on the plane, which is 0, 0, 4. PQ then will be 1 minus 0, 2 minus 0, 3 minus 4, which is minus 1. N, the direction of the plane, 2, 4, 3, in magnitude is going to be the square root of 4 plus 16 plus 9, which is the square root of 29. Then PQ dot n is 7, so using the formula, d is 7 over the square root of 29.